Hey guys, good morning, good afternoon, good evening, with wherever you are in the world. We have quite a few continents represented today. Thank you for joining us. My name is Mike Aubry. I'm an evangelist actually with Autodesk, and then my colleagues this is Chuck Alexander with Solid Concepts, and of course, Princess Aliyah, the head coordinator for the UAV Challenge. Thanks so much for being here, guys. Um, I think we're gonna have a fun webinar for you today. So what's on the agenda is we've been talking with you a little bit about kind of what you wanted to do, and then we've seen kind of what happened from our last webinar that we did with you, focusing in on 3D printing. And so our agenda today is actually very loose, but what we've found is that actually a lot of you haven't gotten into modeling quite yet for your drones. And so for today, we wanted to just start off with some general announcements from Princess Aliyah, and then actually we were going to show you actually a more deep dive into the CAD tool actually that I'm most familiar with, a product called Fusion 360, to get you guys familiar with how to create the correct deliverable to take advantage of the sponsorship that Solid Concepts has put forth to allow you to basically make faster prototypes and try some really creative things with your drone projects. So that's what we're trying to do. So Princess Aliyah, what's happened in the world? I understand there's actually quite a bit in the realm of publications and signups, and there's a lot going on.
There is. Oh, great stuff. Yeah, actually, we just got back from the Bahamas. Yes, I know you wish you were there, Mike.
I do.
Next time when we're
Uh-huh.
we're we're
It's
working towards saving some
uh-huh.
of the animals on that side of the world, I'm sure
Uh-huh.
our teams will be thrilled about the Caribbean and the Bahamas as well. Um, and actually, Tom Snitch, which most of you guys know from the leadership team, he's in Costa Rica right now working on some illegal fishing issues as well. So we are going to be moving to warmer and closer weather to the US. But as of now, we're still focused on South Africa and working to help with the rhino crisis situation. And a lot of great stuff will be coming from the actual wcUAVc as well. One of the things, like the first few webinars were just to get an understanding of how the teams would respond to it. And we've actually had really good response, especially our first seminar was phenomenal. I think Mike and Chuck did just a fabulous job on that. So thank you very much again
Very kind.
for such a great webinar last time, and I'm in for another one. And this time, I'm hoping to actually learn how to design in Fusion 360 as well. So I think that's going to be really exciting. So I just wanted to let our teams know that we will be having some other webinars. So keep a lookout on the events page. The next one I think we're going to end up having is probably going to be on the makerspace movement. What is it? How can you be involved? And one of the biggest news that we would have is for the actual final competition, we are planning on setting up a makerspace at that facility that we would hold the final competition. So that would help for the team. So if there were any broken parts or any issues that you guys run into, there will be a facility that you can actually use to be able to go back in and kind of bandage up your UAVs or any of the issues that you have. So that's exciting news that we will be working on setting up. And I'm thrilled to have Mike Alfani with ADX help
AX.
us on putting that together. So he's actually going to be doing the Makerspace webinar next month. We are, I believe, scheduled for the 19th. Don't hold me on that, but it will get posted within the next week. We're also going to do one on the 8th of April on solar cells and UAVs. And keeping in mind that South Africa is an ideal location because they do get lots and lots and lots of sunlight, if we can actually integrate some solar cells or panels into UAVs, that would be perfect solution as well for that particular environment. However, that's up to the teams if that is something would like to pursue or not. But we are going to give you an educational seminar on different types of solar panels out there, as well as UAVs that have been used with that. We will also do one with FLIR. I've actually got one of the main technical surveillance officers for FLIR who actually joined our TACP network, and he'll be doing one on the different types of cameras. And I am working hard to get our team some low cost cameras from FLIR. I actually have a meeting with them tomorrow. So good news, hopefully next week for you guys
Wow.
on that. And we are also looking at doing an aerostructure um, webinar. and the details of that would be probably sent out within the next couple of weeks as well. One important one that I think the teams will really, really benefit from is going to be a webinar from the pilots who flew in Kruger National Park. So I'm actually going to have John and Larry do a presentation on their experience in Kruger National Park, what they dealt with, and what the team should anticipate. So we're probably going to have that one in March. So I think that will really help the teams have a better understanding of what to anticipate in terms of flight in Kruger. So I think those are just a handful of the ones that we have kind of tied down. But you will be getting reminders and emails and updates regularly about our events and webinars that we'll be holding. And last but not
Look at
least,
that.
the Futurist, yes. Don't forget to get your copy of the Futurist, Drones
Uh-huh.
versus Poachers.
Look at that,
And
guys. We're in the news.
yeah, this is really, really, really exciting. I mean, to be in the Futurist, on the cover of the Futurist,
Uh-huh.
4 months from the time we launched the project,
Uh-huh.
that's a pretty impressive deal. So I'm
Oh, wow.
thrilled. I don't know if any of you have read the article or not. It's a really interesting article, and I kind of started writing it before the actual competition even started. So some of my thoughts were prior to, some of them were after we visited South Africa. So I think you'll find it pretty useful with some tidbits of hints in terms of what would be pretty interesting to see come out of the competition. So make sure you get your copies or go online and at least read the articles. And if I do run into any one of the team members that have a copy of it, I'd be happy to sign it for you.
Yes. That is
All
so
right.
cool.
Well, thank you. That's everything from wcUAVc,
Okay.
and all yours from here on.
Cool. Okay. Well, man, that is so exciting. I mean, 3D printing is fantastic, and that's what we're doing today. But man, gosh, the stuff on the IR side of things. I mean, there's a whole wave of my team that's involved in that. So I mean, we're going to be really excited to see that. And then of course, I mean, actually, I remember I was actually emailing you guys last week about asking if we could interview some of the guys from Kruger. So I am, yeah, I am so excited just personally for that stuff coming up. Thanks for putting that together. Okay, so all right, guys. Well, let's do
Hey,
some
no problem. I mean, I'm
let's do some modeling. So the way things go, kind of over these webinars, so right now there's 17 of you guys that are on out there in I guess in UAV land, and there's three of us. So the way these things work, help us, give us feedback on how things are going. There's a couple ways to do that. So the first way is you guys can send us chat messages. We can see everything down in that chat. As you guys send us messages, we'll respond to those. Actually, there are some questions that have come in. We might want to actually just kind of get some of those out of the way before we even start this. And then the other way we can get it, if you guys are super engaged and really want to participate, we can even unmute your microphones and you can ask us questions directly. Just let us know that you want to do that, and we'll do it. Usually in a webinar this size, we don't want to unmute everybody because there's all sorts of crazy noise and stuff that goes on. So uh, but yeah, let us know. We want this to be interactive from there. So actually, Chuck and I, today we're gonna combine a couple things. Chuck is this is actually his very first time modeling, not modeling ever, but very first time using Fusion. So we're actually we're all gonna learn together today, and I know that
Good.
actually a lot of you guys are in the same spot. We were the reason why we're doing this is we know a lot of you guys you want to take advantage of 3D printing. You just haven't done any 3D modeling yet, so we want to just tackle that and kind of see what does it take to actually create something that you can 3D print. And well, hey, this is going to be it's a brave new world for all of us. So
Right. Do I look like a guinea pig?
I think hey, you look as ready and able and willing as anybody. Well,
We'll see how it goes.
prove me wrong. Uh, Princess Aliyah, are you gonna do this too? Are you gonna join? I
Surprise.
I challenge you. You should absolutely join. For those of you, the rest of you, if you want to participate as well, actually, I'm going to show you literally how to install this software. And as we're going through it, we're all going to model. So if you guys are looking to do something else, let me know here if it has, and we'll cover some other things. Specifically, there's a couple of questions here that have come in just kind of unrelated to kind of where we were going. I'm actually going to start installing Fusion, so I think a big great time to get to some of that stuff will be actually while it's installing. So let's jump into it and get started so we can get started. So can you guys see my screen? You should see like
Yeah.
just a web browser coming up here. So what we're going to do today is we need to, in order to model something, you guys are going to need to have the actual modeling tool installed. So it's a really fast install. Like this will only take us like 5 minutes. I don't know, barring on how far, what kind of web speed you guys are dealing with, it might take a little longer. But if you guys go to this website here, this fusion360.autodesk.com/about, there's a little button here called Try It. Why don't you go ahead and try it? And if you guys are on a Mac or if you're on a PC, so Windows 7, Windows 8, uh, you'll be able to use it. It's actually the same process. It looks a little different. I'm on Windows 7 right now, but the Mac deployment is the same. You'll actually get this thing, and there's just an extra phase where you'll have an icon to click. So go ahead and start installing that, and then you'll get an executable. Go ahead and start running that, and we'll see this guy start to install. And so it takes me here in the Pacific Northwest, where I have a pretty good internet connection, it takes me about 5 minutes, which isn't a very long time, but in webinar land, that's actually an eternity. So fortunately, we've come up with other things to do while this guy is installing as well. But so I want to, while this thing is going, is first off, Chuck, how are you doing on your end?
It is about 10% done.
Oh, so you're beating me right now?
Installing.
Oh, ridiculous.
Yeah, I'm
Okay.
installing it too. So,
Okay.
well,
The link
yeah,
again.
maybe I'm ahead because, our business is based on getting data from the customers. So we make a really big data pipe because we don't want to create bottlenecks anywhere, getting data from the customers to print. So,
So a couple.
but did you want to hand off to me or?
Yeah, just real quick, there was a question that came in around what was the link, and so I just posted to everyone fusion360.autodesk.com/about, and then hit the
Yep.
try it button, and then nice. There's all you guys are trying. This is great. There were a couple actually before I hand off to you. There's a couple things that were non CAD related. I want to just kind of throw out a couple of these things so we don't lose them in the fray. Uh, there was a question that came in from Elmar. I don't know if you guys saw it in the feed here. Actually, let's go actually one up. From I'm going to read it. It's kind of a long one. Let's see who's best maybe to answer this question. Just flat out. I've got a very difficult question, which is very important to the challenge. There is being said that a wave trend active RFID tag is going to be used. However, they're going to be using a proprietary protocol, it seems. This means that we need to buy one of their readers. However, this is far above the limit of $200, 40 points. How should this be handled? I suppose reverse engineering is not the best way it's meant to be. Um, Princess Aliyah, who do you think is best to ask about that? Using an RFID tag. I haven't. Oh, actually, we might have lost. Oh, we lost Princess Aliyah. All right. So on my end, I mean, as a competitor myself, Elmar, I haven't heard about that, but then I'm not on the leadership team, so we might. Let's. She'll. I imagine she'll be back on shortly, so we'll go ahead and answer that one. I'm sorry. I tried to get the question out there. I'm curious too, so we'll come back to that one. Okay. So actually, Chuck, let's go ahead and we'll just go over to you then. We'll go back to the. Just kind of what we're doing here. So what Chuck is going to show us, kind of as this thing is installing, is there's a lot of things you can do even after you have it modeled on ways of actually taking a group of different things you'd like to be 3D printed and put them in a fashion that it's more cost effective and actually more time effective to do. It's a best practice on how you can best take advantage of the stuff you're doing 3D printing. So Chuck, I can see your screen.
Cool. I hit the share button. So actually, we're going a little bit out of order. So we've assumed that we're done with our CAD design. So Mike sent me some files yesterday, and so I want to use some of those examples we're going to be looking at later on that we're designing, and I want to show you how to work with solid concepts to get some parts printed. So what I'm going to focus on mainly, we have two different ways to get a quote. Two different websites. So I'm going to go through the easy one first, which is zoomrp.com. Looks like I've got my install taking over the screen here. Uh-oh.
Hey, there you are. You're installed.
Yeah, can
Fantastic.
I
Well, well, you're gonna need.
can I
Yeah,
click?
we're gonna get you an Autodesk ID in a little bit. Let's see, finish what you're doing, and
Can
we'll
I?
come back and we'll do that.
Right, so
Yeah,
I can just close this and come
yeah.
back to it
You
later.
just reopen it. You'll be fine.
Okay. Um, so Zoom RP, and what I'm going to focus on is SLS, which is a technology that we went over on the last webinar. But SLS makes parts out of functional nylon materials that are filled and unfilled for different kinds of properties. And so on zoomrp.com, we have limited choices of products. The real focus here is getting parts very quickly. In fact, you'll see up here in the upper right, we have a countdown. We can actually take orders for parts today and ship today. We do that in PolyJet in the process. So for parts that are non-functional, or if you're doing design verification, or parts that aren't going to be loaded with a lot of stress and things like that, PolyJet may be a good way to go. So anyway, I'm just going to start going through the process here, and I'm going to maximize this screen so hopefully everybody gets a good idea what's going on here. But for those of you who don't have an account yet, if you go to the sign-in screen like I did, you can create an account, and it will ask information to create an account. But once you have an account, you can just sign in with your email. And a password, which you define.
Hey, you're back.
Oh, did I disappear for a while?
No, 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 no. Princess Aliyah disappeared.
Oh, yeah, I'm not watching what you guys are doing, so I'm just watching what I'm doing.
Hey, man, you're the star.
Right. So I'm just going to quickly upload a part here, and so I'm going to try uploading some of these parts that Mike sent me. So I'm going to add a part, and I've just defaulted to ship today and a PolyJet. So I'm just going to load this motor mount that I think we're going to be working on in a little bit here, and show you how you can upload a part, get a price for it. Huh. It didn't like that part. I wonder if the webinar is interfering. Let me try selecting a different product here, like SLS, see what happens.
Ah, no worries. I mean, in worst case, we'll come back to it because this is the end
Right.
process anyway.
Yep.
Oh, actually, yeah, you guys are actually having some processing things on your side. So yeah, we'll just come back. Alyssa just pinged me, so
Oh,
yeah,
okay.
we'll just come back to this.
Oh, our sites
Um,
are down?
yeah, yeah.
Awesome.
So we'll come back to it.
Do I?
So fire up Fusion again. So for those of you guys, I think a lot of you guys already have Fusion installed. So we'll go ahead and we'll just make our part, and then by then I bet the site will be back. So what you guys will need now to actually log into Fusion, which is why we're doing this to model something, so you can ultimately get it to Chuck and his team to make. We're gonna go into Fusion 360, and you guys will need a login to make that happen. So what we're doing here, Fusion is a product that's actually targeted at small businesses. So we actually have a commercial version of it, but for you guys, for enthusiasts who are, if you're making less than $100,000 a year in revenue for your company, you're an enthusiast. So Fusion will cost you nothing. So to get an ID that costs you nothing, go to that little button down there, need an Autodesk ID, and go ahead and sign up for that. So pay attention to what your ID is, because once you've got it, we actually don't have a way to change it. So make sure you guys really love your ID that you select. And then the email that you use, that's an important one to remember, because that's actually how you are able to share things using Fusion. One of the nice things about Fusion, because it is a cloud-based resource, it's very easy to share or not share your data back and forth with people. And actually that email address is the one that you use to do that with. So this process, this account that you're creating, actually, go ahead, Chuck.
Do I? Where do I get the ID?
Just create one. What do you want? Chuck
Oh.
Superman. Yeah.
Check the
uh,
beginning.
Chuck the Master. Chuck Novice. Ah, man, don't be. Come on, man. It's your
Sandbagger.
ID, man. Chuck and Princess Aliyah. You can be Princess Aliyah. I think that'd be an excellent name.
Oh,
Hmm.
8 characters.
Then, okay, so Gert's still deploying. Okay.
I'd like to receive an email. I agree.
Nice,
Cool. So that's looks like it.
nice. Okay, so now you are. Yep, you're gonna. It's basically it's gonna set up your hub here, and so this is basically it's gonna set up your space, your modeling space that you can use.
Okay.
Hmm.
So I can just get started.
Nobody can hear you, says Elmer. Can't hear me. Can you?
Oh, am I?
No, I
Did I
can.
mute myself?
I can hear you fine.
Oh,
Elmer, can you hear me?
I'm not saying much.
I wonder. Let me quick ask Alyssa. She. Elmer, you can't hear. Alyssa, can you hear us? Oh, no sound from Princess Aliyah. Are you muted? Oh yeah, you're
Yeah,
muted. You're muted. You are. Let's see.
I
Yeah. So Chuck, we can hear you fine. Yeah, Princess Aliyah, you are on mute.
and we're still sharing my screen,
Yep,
right?
you were still sharing your screen. Uh,
Cool.
yeah. So there we
Good.
are. You've got your setup, and actually, for those of you guys that are following along at home, um, go ahead and just say accept the non-commercial terms in use, and say you're an enthusiast. And what this will do is kind of once a year it'll check
All
in to
right.
make sure that you're still an enthusiast. But as long as you're still an enthusiast, be cool. Don't if you're making tons of money,
Right.
you should pay for it. But if you're just like us, I mean, this is a. I know that my team isn't making any money.
Yeah.
You're an enthusiast.
I have evangelist in my job description too, so I can be enthusiastic. All right.
So there's a John's actually pinging and asking if we do stuff that's 64-bit versus 32-bit. So John, it's actually 64-bit only is there. So if you guys are going off 32-bit machines, you're going to need to have a 64-bit machine. That is a limitation of it. I mean, it's a progressive CAD tool, so it's like we've kind of embraced that we're moving away from the 32-bit world. The operating systems we support is Windows 7, Windows 8, and Mac OS. So yeah, John, you'll need a 64-bit machine.
Hey, Mike. Finally, you can
Yay.
hear me, I
Hey,
think.
there you are. Welcome.
Yes.
Yay. Okay. I have a question. Is there an app for this?
An app like on like
Like
the
on an
Good.
iPad or
iPad or
yeah, an iPad.
or an iPad or something, yeah, or Android?
Actually, there is actually if
Is
we
it a free app or do
mhm,
you have to pay for it?
actually let me
'Cause,
well actually as we're going as a natural course of this thing to real quick it's called Autodesk or Auto yeah Autodesk 360 is the app you look for and actually I
okay.
have my iPad I can show you guys kind of
Yeah,
what
I'm
that
gonna
looks
pull
like.
mine up on mine.
hmm
Okay, so it's Autodesk 360.
hmm Uh, oh, welcome. Scott Williams says we have our youngest attendee is 9 years old in Africa, and he's
Oh, yay!
Awesome.
Hi.
welcome. Uh, welcome.
It,
Uh, yeah, so I guess we'll keep modeling here. So Chuck, we'll have you kind of create your first part, and then actually I'll jump over and I'll show some stuff, and you can follow along there. So what you guys are looking at here, if you look, Chuck, you see in the left-hand corner there's this thing called projects.
yep.
This is how you guys organize where your files are. So if you go to your Chuck's first project there, that's a
Yep.
good place to start. And this is so that's one of the ways that you guys can separate and delineate kind of where your files are being stored. And so here you have a mixture of you can see under activity you'll have a reference of kind of what has happened recently in that space. And then there's also an area actually on the left hand side you can see data. If you guys want to see it on a more conventional how things are stored just within a conventional folder hierarchy, that's where your space is for organizing in that manner. So there's kind of two ways to keep in touch with where things are. I'll show some more of that in a hub that has a little bit more stuff in it. But let's get you started just by creating a just a part. So do you see in the upper right hand corner there's a space called create?
Right.
Yeah. At the bottom of that space there's a little F. You can see there F design. That would be a fusion design that you're going to
So
be
the F
creating.
F360 design here.
F360 design, yeah. And so there's other things you can create too because Fusion's both a CAD tool and a collaboration tool. So there are things in there like messaging, polls, and whatnot. But since we're going to do some modeling, go ahead and do this and start making a part. So I don't know, just make your first part. I'm going to be designing a motor mount for the UAV. Um, So that's what I'm going to do. So I'm going to take back control here, and then
Okay.
you guys can follow along. So here I'm going to go back to me, show my screen. Let's see if I actually got installed. Yeah, I'm wondering actually on my end if it actually installed. Oh, we might be going back to you. Oh yeah, while we were talking, actually, like it stalled out on me. Weird. Okay. Oh, we're going
I
back
love
to
it.
you.
Awesome.
All right, hold on. Let me put you
Fly,
back.
fly by wire.
Hey man, it's live, man. Let's go back to you, and I'm gonna quick make sure I get my guy. I'm not sure why I did that.
Oop. Did I share my screen?
Yeah, we can see you.
Oh, okay.
We can see you.
Because I can't really. Let's see if I can pop it open here. Okay. Is this my screen? Oh,
Yeah,
it
that
is
is
my
your screen.
screen.
Yeah, so this is your
Oh,
first experience that you guys will be seeing her. So it gives you a little description of kind of what's going on
okay.
in the space. So actually, I'll run you through this as well, what you're looking at, kind of the key ways to move around the Fusion interface. Uh, for those of you who have modeled before, you'll find it very familiar. But I know actually some of you guys, this is literally your first time trying to model, so I'll walk you through it. Chuck, I imagine you're somewhere in between. So go ahead and exit out of that like kind of introduction bar there, and we'll start modeling something. Um, so this interface you're looking right here, you can kind of see in the upper left-hand corner. There's your modeling taskbar. So you can see it at the very top. There are tabs. See that webinar V1 versus project data. Um,
Right.
that shows that you are actually in the modeling space. And actually, if you go back and click on project data, that will take you back into the collaboration space.
Ah.
Yeah. So that's so it's got kind of a browser-esque kind of feel to it. And so yeah, if you go back in the modeling and how we would model, Fusion has within it actually three different ways of modeling. It's what we call, it's a very flexible CAD modeling tool. You can model with what we call conventional solid-based modeling, where we're doing things like extrusions and fillets and stuff. That's what we'll be doing primarily today. We also have a sculpting environment where you can kind of push and mold things, where you're moving things around. And actually, if you see there on the left-hand corner there under Create, there actually are those two different forms there. You can see one's a box and one's more of a more sculpty round thing. So we're going to be doing a lot of stuff actually in the box today. And so I figured I'd have you guys just make, just start modeling like a motor mount or stuff. And so if you click, actually, Chuck, let's have you start modeling something. Go
Okay.
ahead and that creates thing. You see there's a little triangle below where that box is, then create. Go ahead and pull it up in there and we'll just make a box. You can start moving
The
things around.
little triangle thingy.
Yeah, you see, and left of model, by create, there's a box in the upper left-hand
Left.
corner. Yeah, that guy. Yeah, click on that
This
guy.
one?
Nope,
Nope.
nope. You see
Which one?
modeling?
This one?
Yeah, modeling. To the right of it, there's a blue box. Yeah, click on that guy.
Right.
Yeah.
Okay.
Uh-huh. And then actually just below it, actually, a little bit further down, click on that thing. There's a
This
little,
thing?
little triangle right below the blue box.
Pull down the
Yeah,
menu.
and actually,
Oh, okay.
I'm going to literally we're going to do a really super complex first model. I'm going to literally have you model a box. hmm
Awesome. So, box. Is
hmm
that what I wanted to
Yeah.
do, or?
hmm
Okay.
Yeah, and we're going to model it. So go ahead and click a plane where you'd want to create that.
Okay. Kind of. So I'm used to XYZ.
hmm
Is this the XY plane? I'm trying to figure out how I'm looking at this
Absolutely.
modeling
Yeah,
space,
and
but
that's going to be something you're going to want to care about too if you're going to create a 3D print, because of which way things are oriented. And actually, for those of you guys that are trying to do things like laser printing, that actually matters as well, or laser cutting, that matters. The way you would actually take a look at what that is, on the left-hand side of your screen, there's this thing called the browser. You can see that there actually is a
right,
folder down there you can see for origin.
right.
If you see the little caret to the next of it, the little triangle there, if you open that guy up, you actually can see where the different planes are: X, Y, X, Z, Y, Z. If you hover over them, it'll actually highlight which is which. You see the X, Y plane down there, right there. Yep, there you go.
XY.
Yeah, you see how that's how you can see what's going on there.
Okay.
Um, okay.
Sorry.
No.
I'm trying to
This is
understand. I
important. Yeah.
shouldn't try to understand. I should
So I
just
was gonna
do
have
it.
you.
So
No, so we're gonna have to do this stuff. I might have to take a little bit of a sidetrack so I can figure out kind of what went on mine. What's crazy is I actually
okay.
uninstalled and reinstalled like 3 times before this webinar, and so I think I finally taunted the temp folder gods on my machine. So I might have to figure out what I did
Oh,
in my over zest of prepping here. So, but let's
But
make
you know,
sure we
it's a
get.
good thing that Chuck is doing this.
I'm gonna give you guys enough to hang yourself so I can go troubleshoot on my end.
oh, look at
Let's.
that. I've got a 50 millimeter grid.
Mm-hmm. Yeah, so you see that the way Fusion sets up is there's kind of two ways to model in the solid environment. You can do things just by kind of snapping to places on the grid.
Right,
So you see that there's grid properties there. If you hover over them, you can see how those will just highlight to things. That those grids are a function of how far you're zoomed in. Um,
right.
and so for zooming, I'm just kind of navigating around. If you guys have a three-button mouse, Fusion really likes people with three-button mice. We've had people that have used just the trackpad on laptops, but actually your best experience will be with a three-button mouse. And so that zoom option is actually with your scroll wheel, and that'll zoom you in. Where your cursor is, that will
It's the center.
determine where you are zooming. Okay. And then the next thing you have, if you click and you hold down on that center mouse button, that will be your pan.
Awesome.
And then your next super secret code key to hit is the shift key. If you click and hold down the shift key, and then click and hold down on your middle mouse button, that is your rotate.
Awesome.
And those guys combined, there's a couple other kind of things in there, but that'll give you guys enough to do damage right now. On the rotating, I always like to talk about. You see in the upper right-hand corner, there's a cube that has things like front, top, left, right. That's called your view cube, and that's a great way to go ahead and just get things on your orthogonal planes, make it so things are nicely aligned. And another place to look, if you guys are using just your track pads and aren't using your mice because you guys are just too cool for that, in the bottom of the screen there, Chuck, do you see there's a big hand? Not a big hand, a tiny hand in the bottom, and then
Tiny
there's a
hand in the
tiny hand.
bottom here.
Yeah, those are your ways to get away from using a mouse. So you have things like pan and orbit. One that I always like to show is that fit button. So
Yep.
hit the fit button, and you can see that if you ever get like totally zoomed in or zoomed out, that fit button will nicely frame your model. And so those are.
So if I lose it off the screen, I can go to fit and bring
Yeah.
it back.
hmm
Cool. Awesome.
So those are the ways to kind of navigate around, with the modeling space. One other tip for it, actually, I'll show you one more thing on navigating when we get this part created. Let's make your box, and it's a wonderful looking box. So you can see those see those handles. You can actually kind of move things in and out, kind of size things up. You can do it here. You can size things up later. So you'll notice that it's actually pulling on snap increments. And so those snap increments are
Right.
actually a function of how far you zoomed in. If you zoom way in, those snap increments will become finer. So right now it's going on 25s. If you zoom in, it'll go down to 1. If you zoom out, it'll do 10. It'll do
Right.
um, you aren't.
So yeah, it looks like it's snapping every 5 when I'm dragging it, but, every 5 millimeters. But cool.
Okay.
Awesome.
I'm looking at some of the questions here so far. Okay, so some people are saying, yeah, having to go into full screen to see some stuff. Yeah, good feedback.
How's
And then
that?
Stefan's asking, what is the expected duration of this webinar? For those of you guys who have time crunches, uh, we were. I'm sorry for not expressing that at the beginning of it. We were thinking to go about an hour. So we're at 8:30 now. We're probably checking around 9. Anything that if we keep going long, I know that Chuck, I believe we're good to go a little longer than that if you guys want us to. Um, so this is all going to be recorded. So if you have to leave, don't feel free. We can it'll be online. You can check back in. And yeah, and if we need to do follow-up sessions and stuff, that's definitely something we'll save a call to action. Um, yeah, so that's we're right there. So Chuck, let's go ahead and we'll go ahead and make that body. Do you see in the box there? There's a space under operation called new body. There
Yep.
actually is a way you can make a new component as well if you want to do assemblies. Um, we're not going to get to that here. We're just going to design a simple part. So we'll just leave it as a new body. Um, And I'll talk a little bit about what a body actually is as we start playing with some of the other tools. But yeah, so go ahead and let's make your box.
Okay.
hmm Say okay.
So just say
Say
okay.
okay.
Oh, no more
Whoa!
controls.
Totally crazy, huh?
That was hard.
Yep. Pretty nuts.
Yeah. And
um,
it's actually kind of a solid cube thing. So can we turn it into a box?
sure can.
A hollow
You
box?
sure can. Yeah.
Cool.
If you want to turn it into a hollow box or whatever, let's kind of show you some of the ways to manipulate it. Um, so what you set up here is you've just made a basic box that you can kind of shape around there. If you actually click on a face, like if you just click and right click with your mouse on it, you'll see it'll actually pull up what's called your marking menu. And so there's the kind of two different ways to interact with things in Fusion. You can use this right click marking menu where you have all these options, like we're going to use that thing called press pull. But you can
Press
see
pull.
there's actually a whole bunch of other things like modification and creation steps, which are actually available in the upper left-hand corner as a part of the modeling, the taskbar. So yeah, I'll show you some of those differences here. But let's just have you, how do you manipulate things? The press pull is a good one to use. Uh, uh, Go ahead and say press pull, and then click on a face. So just click on one to move, and then yeah, pull it out, and that's how you're going to be able to move some things. Yeah, so that's how you can move things. So
Yeah.
you can use your snap settings, or you notice actually in that space there for that distance, you can be explicit as well. Go ahead and move
Right.
another face, and we'll show that. I'll show you some other ways to be explicit. That's one of those things like with modeling, like you have kind of there's two different kind of ways people reasons people model. The first one is conceptual modeling about how do we visualize what's going to be there. So you're just trying to get things good enough so you can see it. And then in when we're actually getting to a point where we need to manufacture it, then you're trying to be exceptionally precise. I mean, 3D printing is a very precise operation. And so here, like, so Chuck, if you actually say you wanted to do 63 millimeters, you can actually mix and match units too. If you want to do 63 millimeters plus 1 inch, because we are in the United States after all, why wouldn't we want to make it a little bit more difficult than it has to be? You can actually do that as well. We can do things like equations and whatnot. So actually try that. Just do like 63 millimeters plus 1 inch, and you can share that. There are reasons to do this actually,
I
even
like
if you're
that.
yeah, even if you're
Oh,
globally.
awesome.
I mean, there's just some stuff. I mean, sometimes you get on the internet a cheap imperial, tooling. Hey, I was able to get this awesome nut and bolt set that's from the U.S. So if you need to mix and match your units, you can. So that's exactly right. You don't have to worry about converting it. Pretty handy.
Cool.
Uh, so okay, so there you got this really sweet looking box. Let's add some functions, some features to that. Let's just start by adding maybe just a round to that outer edge. So maybe start by clicking on, yeah, click on that guy, on that top one, and then hold down the shift key, and then click the line below it as well. So we'll highlight both of them. And then right click, and we're going to add a fillet. And then you see the little arrow that appears down there? You can click and actually just drag that in there. Just drag on that
Just,
arrow. Yeah, just drag that guy
oh,
in. Yeah.
oh, awesome.
Yeah.
Oop.
Yeah.
Hey, I made it
Pretty
disappear.
crazy, huh?
That's awesome.
And if you hover, if you get it just right, you can even join the two together. Like if you want to just make it in one combined round, if you get it right towards the center, it should be able to identify. You might have to. Yeah, there
Oop.
you are. Yep. A little more. There you go. Yeah.
So it's
So
spherical
it'll
now.
combine them. Yeah. So you now have a nice round on
Awesome.
there. Pretty handy stuff.
Cool.
hmm
The number looks right too for my 50 millimeter box height. Anyway, awesome.
Love it.
Imagine that.
hmm It
It
looks
does the
it looks
math.
beautiful. Absolutely beautiful. So
Yes.
okay. So now we have to actually go ahead and say okay. I mean that looks fantastic. Yeah, if you want to change it, I mean you can use that little you can do it graphically in there, or you can yeah, enter precise values. I mean this is all stuff that's you can kind of choose your own adventure. There's a couple ways to do it. Uh,
Right.
Quick question from John: can we do ray tracing? Yeah, actually, when we're done, actually, Chuck will have you make a really sweet rendering of this. Um,
Oh,
okay,
cool.
let's add another feature to it. If we're gonna do
Okay.
let's add a hole. We'll add a hole to this guy. So to do that, we can do that by creating a sketch with a point. Maybe we'll do that, but actually to start with, just click on that top face and right click. Maybe where the round is, the flat face for the round. Let's have it so it goes through, so it'll be actually concentric with where that
Oh,
radius you
this
just
face?
created. Yeah, yeah,
This.
yeah.
Okay.
So go ahead and you're selecting the top face. Select that side face. I'm going to be very precise. I know exactly what I want you to do. Select the side face there.
Okay. All right, cancel. Select.
No, select the. Not, I'm sorry, not where the round is. The one that's actually going to be normal to that. That guy.
This
Yep.
one.
Yep. Right click. Yeah. Do you see there's an option to create a hole in the under your marking menu there?
Oh, right.
Yeah. Let's make a hole. Because holes are fun.
Oh, wow.
So you can move around actually. That you see that little plus thing that's in the middle. You can actually click and you can change your, as you see, change your diameter size, and actually you can move where that hole is. Actually, you see that center place. Click and move that around. You can just throw it wherever on that face. So you can just like, whoa. You move it around, or you can pull back. It'll figure out where that center is. Actually, around there, you can see it'll snap to it.
Yep.
Yeah. So you can snap to that guy.
So now it's concentric
Mm-hmm.
with the outside radius.
Correct. Yep.
Awesome.
And then you got to make sure that it's going through. So you might want to get a different view to make sure that guy is going all the way through. Or maybe you don't. This is your part, not mine.
See, I'm trying to remember how to rotate. Oh, awesome. Look at that.
hmm
So I could just drag it through, right?
hmm
Cool.
So that guy's going through. And then go ahead and say, okay.
Cool.
So
This is too easy.
nice looking hole. And I like to hear that.
Of course,
Now
it's a fairly.
we're gonna pick up
Yeah.
the difficulty a little bit here. I mean, by the way, I'm
Okay.
flying crazy blind here. This is not the way I saw this webinar going, but
No, we thought we were going to be designing a motor mount.
we are. We are. No, no, we'll get there. We're gonna.
Okay.
We'll get there.
Okay. But this is good because I think, like I've never used Autodesk or any CAD software. So it's really helpful just to see it from a very simplistic um, situation. So I'm glad Chuck is working on this and not me.
Yeah.
Are you playing
I'm
along
good
at
at.
least?
You
Yeah.
know what? I missed the first like 10 minutes of whatever you guys were doing
Ah.
because of me having to reboot. So I did eventually get to some point, but I lost you, so I'm watching.
Oh, it's so boring. You need to play along.
I know.
I'm gonna get you into Fusion.
Private lesson. I
Mhm.
think this just means I'm going to need a private lesson, Mike.
Done. Done. All right, Chuck. Well, we gotta pick up the difficulty here.
Right.
You've had it way too easy. So
Okay.
what I need you to do now is we're gonna make a motor mount. So we're gonna have to at some point have four sides of this. But let's make another hole in the center, just a different way, so that we can show that there's other ways to do this, just kind of beyond the direct modeling method. I want to get you familiar kind of with how to make a sketch. So
Okay.
on that top face, we're gonna add a hole that's a little bit on the straight there. So the same face where you created your hole before. Right click on that, and we're gonna make we're gonna make a sketch.
Oops.
And I'm seeing
Oh.
Elmar is asking for help. Help! What do you need, Elmar?
Okay. Am I in the sketch menu? Looks like I am.
You are not in the sketch menu quite yet. You are close though. Um,
Oh.
so are you? Yeah.
It says
No,
stop
yeah.
sketch.
You're gonna. Yeah. Where's your? Yeah. You're not in the
Oh, here we go.
sketch. Yeah. Create sketch is what you want to be. Yeah.
Right here.
Yeah. Create the sketch.
Okay.
Yeah. So.
So now I'm in
Yeah, now so
2D mode.
now
I
you're in
take it?
you're in the 2D mode. So actually, it's a 2D mode on that plane. So one of the
Okay.
things I like to do is I like to get the right view. So you might hit that front view in your view cube. John has a question. Can you make a hole not straight through? You sure can. If you want to do it at different angles or whatnot, there's tons of ways to do that. Yeah, John, we could probably play with that a little bit if you want to. At some point, I'm gonna have to get Fusion up and show something, but I'm having too
Yeah.
much fun right here.
Yeah. Fly by wire. I feel like a puppet. It's cool.
Yeah, you are a puppet. I'm actually reminded. I'm looking at kind of where we're at on the time here. I wanted to Princess Aliyah, I wanted to throw a question to you and your executive team that came up earlier. And maybe kind of while you're addressing that, I can kind of troubleshoot on my
Okay.
end. There was a question that came out actually that Elmar asked that was actually engaging about a rumor. Actually, let me just read the question for you. So it's being said that the said that a wave trend active RFID tag is going to be used for our competition. However, their proprietary protocol, it seems. This means that we need to buy one of their readers. However, this is far above the limit of $200 of 40 points for the competition. How should this be handled? I suppose reverse
Can you
engineering is not a way it's meant to be.
Well, you know what? Who's the ideal person to answer that question? And we have him on here is Scott L.B. Williams. He's in
Okay.
South Africa and he's working on the RFID tags, especially for the final competitions. So if you can unmute Scott,
Okay.
perhaps Scott can take that.
Yeah, here, Scott, I'm going to put you heads up. We're going to find out. Okay, Scott, I'm going to unmute you. Hello, Scott. Are you by your microphone
Yeah,
by
I'm
chance?
I'm up, Michael. Thanks.
Oh, hey. Well, good morning.
Or good evening.
Yeah,
Good
it's
evening. Yeah, that's right.
evening.
You're yeah, you're other side of the world. Good evening.
Y- yeah, so that is true. There are going to be RFID tags, assuming all is well with the world for the finals competition. They'll be fielded. I think the idea is to get their brainwave thinking on what the best way to interrogate those are. However, I have to say I haven't heard too many people come up with what you would want to do that for. So yeah, I don't know how to answer that exactly, other than uh, maybe we can talk about that amongst the leadership team, and we'll try to come up with it. If there's a cost problem for getting a reader, if someone incorporates it, we'll help them do that.
Okay. Okay. Let me. There was another.
That
Did that
did that
answer your
answer his
question?
question? Basically, I guess the answer is, Elmar, let us get back to you about that. We'll talk to TACP. We don't want to put any extra costs for the teams. So if that's going to be an issue, we'll find a way to go around any associated costs with that for the teams.
Okay. Let's see what he's got. And there's another question that Elmar had. I'll read his thing. Another question. How will the concept report be handled regarding the details of your design? I can imagine that some teams wouldn't want to disclose all information with other teams.
Can you actually do me a favor, Elmar? Because this is going to go beyond what this particular webinar is about. So if you could shoot us an email, and we'd be happy to do like a Skype call with you to answer all of these questions, as well as if other teams have them, we'll go ahead and post them on the website as well. But I think if we get into the details of the design concept and the other aspects of the challenge, that'll take away from what this webinar is about. So if you could please just shoot an email, and I'll make sure we get the TACP on that for you. And like I said, if you wanted to do a call with us, we'd be happy to do that as well.
Okay. We'll see. Okay. Yeah, we'll see if he writes back. Here we go. Okay. Okay. Thank you. He will be sending you an email
Okay,
shortly.
sounds good. Thank you,
Okay.
Elmar.
Thanks, Elmar. Okay. So let's see. Do we have any other kind of outstanding questions here that I'm seeing? No. Okay. Well, we'll keep modeling here. And actually, time-wise, we're doing really well. Actually, I think we'll be fine. Actually, without me even opening Fusion. Actually, this is great. We
Cool.
were okay, so we'll do two more things here. I want to show you kind of how to make stuff in a sketching environment, and then I want to show some stuff of how to pattern this thing out, and then maybe make some quick edits to it. And I'll show you some of that stuff. And then the final thing would be let's how can we share some stuff? Being share stuff. So we'll try again to how do we export this so that we can get it to solid concepts, and then we'll try again and get your stuff up into the solid concept system, and we'll call it a day. Sound good?
Great.
Okay. So we'll quick model a hole using conventional sketch geometry as opposed to just the Fusion modeling functionality. So to
Mhm.
get there, you can see actually you see up in the ribbon there. There's a line actually. The little triangle below it is is actually where you have all of your different sketching tools. So you can actually within Fusion, for those of you guys, if you have done some modeling before, we can do what are called parametric based 2D sketching, where you can establish relationships between this geometry we're going to create. We'll make some of that here. The quick one would be let's make a hole. So yeah, pick a center diameter circle there, and then kind of choose where you want it to be. And so you can see that you can snap it to a certain place if you want to turn on your snaps. If you don't want that snapping functionality, actually we can turn that off too. Let's keep the snapping turned on here. Yeah, just pick a place kind of on the center there, and then yeah, pull that guy out, and we'll just create it. So you can either pull it to the length you need, or you can actually on the keyboard enter the size you want. So I don't know, pick something 10 millimeters, whatever. Just pick or need yeah, and then hit return, and then
Right.
actually hit return again, and it'll get you out of that space. And
Cool.
there's your space. So we can. So can we edit these things when you get it done? Yeah, you can actually. Actually, if you click on that guy once, that value will come up. That now has a dimension. So that dimension right there, if you click it up, you can change that from 10 to 15 or whatever. So try that. Try changing it. Yeah, 10 to 15. It's easy to change those things. So you can do things in terms of lengths if you want to deal with how far things are, or in this case, just diameters. And you can set up those types of relationships here. So just to let you know, that's the sketch environment here. That was a really quick overview. Let's take that and we'll go back and model it. One of the common areas we see that new users can get a little hung up in Fusion is understanding if they're in the 2D environment or the 3D environment. And so for you guys watching here, one of the ways to know are you sketching or not sketching, you see how there's a grid there that's on that plane. That's one of the ways I'm able to graphically see I'm in the sketch environment. And then the next way you see, actually, do you see up in the task? So the ribbon up there. Do you see there's actually a icon called Stop Sketch? That guy. If you see Stop Sketch, that means that you're in a sketch. And that's one way. The final way, do you see in your browser to the left? There's actually a folder called Sketches,
To the
and to
left.
the left. If you open up
Here?
yeah, scroll down. You see there's actually a folder called Sketches.
Oh, right here.
Yeah, you see the left. Open that guy up. Just hit the little caret there. Yeah, that guy. That's your sketch. So actually, if you hover over it, you can be like,
Oh,
oh yeah, there it is. So that's ways. Sometimes it's not am I in a sketch? What sketch am I in? So that's a way you can help figure out which sketch you're in there. So yeah, you can do that. John actually made the obvious comment. Yes, you can also rotate it and see what you're going on. I totally agree with you, John. That's a fantastic comment. And yeah, so that works. John just asked me if we have layering in Fusion. Actually, we do not have layers in Fusion. The old version actually did, but this one doesn't deal with layers. You just have flat out just sketches. Okay, so
You
we'll
know
go.
why they got rid of layering?
Oh, because we live in a dark, terrible world with cruelty and change is inevitable. I don't know. Do you want them?
I don't know.
Princess Aliyah said she wanted
You,
layers. We could see what we could do.
no, I didn't say I want layers. I'm just saying. I was just curious as to why they decided to get rid of the layers.
Well, I guess without digging too deep into the history of CAD, the concept of layering is kind of for traditional 2D drafters, layers are heavily relied upon.
Right.
Fusion is targeted at a casual 3D user for conceptual modeling, and so there's a layer of complexity we were trying to
Hmm.
remove actually by having it kind of less ways to sort
Yeah,
things. Um, so we think there's elegance in the simplicity, but if
I agree.
if we have a user base who wants layers, actually we have done layers in the past, actually even within Fusion. Uh, this leads me into a space actually kind of what Fusion's doing in its development. We are now in our second major release, and we're heavily determining where we're going to go based on user feedback. So actually, if you guys get into Fusion, and you really want to start using it, actually on that same web page where we were to download it, there actually is a forum that is called you can actually go and it's called user requests. And what we do actually every quarter, we take a look at the user requests on a basis of what they were requested by and how many people gave them a kudos, and we will sort them for priority that will determine our next round of development. So if something like layering is what you guys see you absolutely have to have, so if John and Princess Aliyah, there's two kudos. um,
All
that's
right.
stuff that actually is determining where we're going with our product. It's really important to us about making sure we have something that's going to be relevant. But anyway, I digress. Let's make another hole and let's print something. So go ahead and exit out of that sketch. Stop the sketch. Hit the little check mark, and now we're back to normal. Um, and then you can click on that, yeah, click on that profile there. And then, yeah, if you can right click and do the extrude. That's something we've been doing. Let's do it another way, just for giggles. Uh, Go to you see under create up in the ribbon there, where we were before. Go pull down that menu again, the little, yeah, that guy. And then the way Fusion operates is you can create geometry or you're modifying it. And so in this case, we're going to create the hole. You can see there's actually extrude there. Go ahead and create that. And you can do the same thing, by the way, with a right click. We actually have both things. I just wanted to show you that there's another place where you can go and access this information. So
Cool.
yeah, so now you can go ahead and actually pull it out. Go in the actual view space. Pull that guy out so that it's not a hole, and actually, so it's like a bar. Uh, okay, and now the fun part. Go and pull it through the actual part. Go and with that arrow, go pull it back through the part.
Oh, the
Yeah, just it's gonna be
I get
crazy.
it.
Throw it through. All right, you see what it did there? So what we're doing is it's moving from, is it creating geometry or is it taking away? And what it sees is when it goes back through volume, it'll turn it red. And what the red means is that it's cutting. And so we're actually now cutting. All right, now super fun part. Um, go rotate it around to that back face there. You see how you're going through? Actually, if you want to make it so it goes exactly to that face, one kind of nice thing I think about the extrude, go rotate to that back side there so you can see the back face. Okay.
Forgot how to pan.
No, you're good. You're good. Um,
Okay.
Go just click on that face. So quick, pull that guy a little bit.
On this
Yeah,
guy?
just click that face there.
Oh, cool.
Yeah, see what it did? So if you guys are extruding things and you want to extrude it to a thing, when that's kind of a fun little tip of there. If whatever you can actually make it so it'll extrude right to just with a click. Just a fun little tip for you. So you've got to cut through, and that's so what we've done there is we've made a sketch and we've done a quick extrusion, and so that's just another way for you guys to create a hole. So we're coming up. We're very close to 9 here. How about we I, how about we go back and show how to get this to 3D print it, and then for those who want to stick around, we can finish the part. Does that sound like a
Okay.
good idea? Okay. So if we want to, so imagine that this is exactly what we need. We've made this amazing part. Go ahead and hit OK.
Okay. Where's okay?
It's underneath your 30 millimeters there. So yeah, if you hit return there, so that'll hit return or enter. Yeah, there you are. There's your guy. Um,
Okay.
so now we're ready to make it. Let's actually take a look at what we've made. Do you see at the bottom of the screen? There's a like sort of like a video cassette kind of play unplay thing. The bottom left. That's actually called the timeline. You can actually go back and forth on this and actually see what it took to create your part. This is actually a way this is our version of what's called parametric modeling. We call it iterative design. And so this actually, if you go and put that back to hit that far left button, you can put it back to the beginning of the part. Hit play, and actually you can see what it took to actually make this part. So it'll cycle you through it. Actually, let's do it one at a time so that the web refresh will work. Just go. You see that second one over? Yeah, just go one frame at a time, and actually we can see what it took to make the part. Um,
Right.
so this is what makes this exciting for you guys that are operating on teams. Being able to capture this step-by-step showing of what happens allows you to, one, if you want to make a change, you can go and edit things. And the other thing, just this way of showing it on just kind of start to finish, it allows you to communicate to your other teammates how you made it. So if somebody else has to go in and use it, this is just a lot easier way to communicate what's going on. So that's kind of a fun thing. We actually literally just added that. So actually, I'm really excited to see what you guys think of it, if whether it's something you like
Makes
using. Um,
makes demos a whole lot easier.
mhm.
Yeah,
So
wow.
Gert actually just had a question if I could show a basic sensor ball. Gert, I don't know if we're going to have time to do that today, but I'll tell you what, if you want to follow up with us, I mean, actually, a couple ways to do it. I would love to work with you, Gert. If you want to do it, I'll model one with you. And then the other thing, if there's enough of you that are interested, I'm more than happy to pop on, and actually, if we want to have Chuck, model, maybe both of us could do more of these. So I'll throw that out there. If you guys want to do these, just open invitation. I'm happy to do that. As both a Fusion guy who loves it, and then also as a competitor, I want all of us to be as competitive as we can in this challenge. So yeah, Gert, I will get in touch with you about that sensor. Okay, so we want to print this. So what you got to do, first off, go ahead and hit that save button. So Fusion will save by default every 20 minutes. That's one of those things, and what's nice thing, because it's stored in the cloud, actually, this is if you went and logged in on a different machine, or if you shared it, it would be accessible to whoever you want to have access to it. The other way you can do it is actually through a manual save, what we're looking right here, which I like because I actually like doing the manual save because you can add like descriptions. Whenever you reach a milestone, you can add that stuff and it'll show up. So now that's something you have. Now to get it out of Fusion, to be useful for 3D printing, you need to export what's called an STL file. There's a couple ways to do it. There actually is an export tab in the browser space, but actually the faster way to do it, I've found, is just choose the body or the part that you want to export right here within the modeling space. So actually, if you right click on that body, there's actually an option to save to STL. See, right there? And so that guy, there's a way, actually hit that preview mesh, and you'll see what it does. What basically it's going to do, it's going to tessellate the file, so it's got all these really cool triangles and stuff. And so this is putting in the format that the 3D printer needs to understand how to cut and create it. So what you'll see is as you change the deviations, the various knobs and fun things, you can increase or decrease that precision. Basically, the cost is it's a heavier file and it can take longer to process, but the benefit is it's going to be more precise. There is actually a custom option of just if you want to go put it out to just high, medium, or low. There are defaults that seem to be, well, I don't know, Chuck, I'll ask you. I sent you the high detail one yesterday. Did it work?
Yeah, they're fairly simple files. So yeah, the high is fine. Now when we print, we can always de-res things. So basically, what we're talking about here is part the file resolution. And so we have software that if it's there can be files with complex designs that will bog down our slicing software and the other software we need in order to 3D print. And so we do have software that can de-res things.
Mm-hmm.
Uh, and then also, if you have, I assume you have the ability to export IGES and
Mm-hmm.
step
Yeah.
files,
Mm-hmm.
so we can work with those as well. But STL is the most direct route.
Mm-hmm. Yeah. If you need to go the other route, I mean, so let's, I guess we'll take this guy and we'll move. I'll show you where that other space is if you guys want to do on other file formats, because it's kind of buried. I'll just show you where it is. So yeah, so here he's going to just save it out to, I mean, so he'll just save it to his desktop, and then he's going to show you how to put that into the system for Solid Concepts so you can print it.
Cool.
It is cool. This is fun.
Yeah. You guys make
Mm-hmm.
such a great team. I mean, really good.
Hey.
Yeah, I did not see this webinar going this way.
Well, both of you did a fantastic job.
Thanks.
See what I got.
Well,
Hey, look.
there it is.
There
Love
it
it.
is.
That's my STL file viewer. It's a
Oh,
Solid View is a software that we make at Solid Concepts. So that's another thing you can have to look at STL files. But there it is. It's awesome.
now is Solid View available for the teams, Chuck?
Um, yeah, I haven't. I'm not real close to our software group, so
Mhm.
I don't know. We used to have you could download free viewers,
Okay.
and well, here let's just take a look real
Yeah,
quick.
where
Because I
is
know
that?
that we have a
yeah.
Zoom Rapid quote on that as well. So if they open it on that, they could automatically submit it to the Zoom.
Well, if you have an STL file, you don't need the viewer, but the viewer will show you what you're going to get when you
Okay.
what the resolution is and how you might what it'll look like when we print it.
Maybe Alyssa can answer for us.
Here, let me actually promote Alyssa so that you can see
Yay,
these questions.
Alyssa,
See, there's
you're
stuff
getting
coming in. Hey,
promoted.
Alyssa, heads up. I'm
You're
I'm
getting
gonna
promoted.
promote you to a panelist.
You're live.
She's fantastic. I've been working
There we
with her
go.
since we started the challenge, and she's been just super duper about getting information out about the challenge, as well as solid concepts and how 3D printing can really make a difference with the future of UAVs as well. She has a great article out in, what was it, Robotics Tomorrow,
Yeah,
I believe.
that was a good
Yeah,
article.
that was a really good article.
Um,
Thank you. Can you hear
yeah,
me?
we can hear you.
Hi,
Hello.
Elizabeth.
Oh, thank you. Hi.
Hi.
Welcome. Thanks for thanks for having. I always love it when I just promote someone. It's like, well, you didn't know it, but you're a star. There are a couple questions for you guys coming in. There was one asking, can you edit a part when you're in that model that's here? When you're actually, I'll just read the direct quote question. It was, can you edit with solid view?
Sure, solid view can do things. We can modify it, so I could change the scale of it.
Okay.
I could mirror it. I can combine it with other STL files, translate, rotate. These move, translate, rotate, align. Those are mainly for us to determine the orientation that we're going to build the file when we send it to the machine. So if I look at, so this is, if you look at the X, Y, and Z axes down here in the lower left, the Z is on all the machines, that's the tool axis, or that's the layer, the axis that the layers are going to be laid down. So when we orient it apart, so for instance, this part would be sliced in this direction. And I wonder if I could show that too. Where's my, here we go. So if I slice on the, I think right now.
Chuck knows 3D. That was one of the comments.
Yeah, well,
You're getting so many props for your skills.
yeah, right. So if I look at slicing on the z-axis here, you kind of get an idea of how a part is built. Let's see if I can. Oops, let's show the other way. So this is doing real small increments. So I don't know if you can see it on the screen, but the part's actually growing, and I'm looking at a section of it looking inside. So this red area is telling me that that's an internal surface. The blue is an external surface. So
That's cool.
if I change my step size here, it'll probably.
Yeah, that's
Don't
handy.
know any-
We're using a very simple part here, but yeah, I mean, when you're talking about, gee,
Yeah.
where's the thickness? Going to be too much, too little? That's useful.
Right. So now we're unbuilding the part. So but anyway, that gives you the idea of, if you look at these yellow lines here, that's, basically what gets drawn on a 3D printer, and this area in between in the red gets filled in. Different technologies, it fills it in different ways. So anyway. I hear someone talking. Cool.
Oh, sorry, that's me
Cool.
in my room.
Yeah.
So anyway, yeah, there are ways to manipulate. Cool things here is that there are certain, when we're in additive manufacturing or 3D printing, there's a certain bottom end as to how little material you can add. So if you create, for instance, if you were creating a wing and the trailing edge of it went to a feather edge, so it went down to 0, you wouldn't be able to create that as modeled in additive manufacturing because we can't add nothing. So, of course, if you're machining it, of course, you can machine away to nothing. And so a lot of times we might make things oversized and then we sand it back to get things like feather edges or smaller features and things like that. So for instance, where that might come in is on this hole where we have a thickness here between the ID of the hole and the OD of the outside of the part. I'm working in millimeters here, so at least I think that's what I'm working in. Let's see. So yeah, this is a 10 millimeter type of, I'm used to working in inches. So if you ask me what thickness things can make, I'm not going to be able to do the conversions real quick. So one of the things I might modify is the units on this file. And so I'm going to tell it came to me in millimeters. I want it to go to inches. So I'm going to scale this object, right? So now I can see, oh yeah, 10 millimeters. It sounded like a little amount of material, but it's actually quite a bit of material. So I don't have to worry about that minimum feature size that I can add in additive manufacturing. So minimum features all depend on different technologies. Sure. SLS technology, where we make a lot of UAV parts, 0.03 inches or 30 thousandths of an inch would be the least amount of material that we could add. So this is over 3 times that amount, so no big deal. So this SolidView software too also has tools in it where you can analyze wall thicknesses, and I'm just going to enter in a 0.4 inches as a minimum wall thickness now that I know what it actually is. But if I say analyze this part, it should show me areas that are under 0.4 inches. Let me go up to 0.5, and because I might have been too close to 0.4. It should, after analyzing, it should show me thinner areas than 0.5 in red. So I don't know why it's not right now, but maybe it's because I didn't save the file after I converted the units, so it may still be thinking it's millimeter units in there. So anyway, SolidView has a number of different tools in there that you can manipulate STL files if that's what you're given. And that's what we're given all the time to 3D print with, because eventually, whether you send us native CAD files or you send us IGES or you send us STEP, we're going to have to get to an STL file in order to print it, because all 3D printing equipment uses an STL file. It has to have an STL file to build with. So I think that's enough with the SolidView. So let's try the ZoomRP site again and see if I can upload a file now. So I'm going to try printing this part in SLS. See if I can add a part from my desktop here. So where's that little test file? Let's see if it'll upload this one. Didn't like the motor mount for some reason.
Hold on. It's too large.
Yeah, it's too large for the particular ZoomRP. So Zoom is all about quick and rapid delivery, so we can limit part sizes. But you can see that this part, oh, I didn't save it as inches, so the reason why it's too big is that it thinks it's in inches. So what I need to do is update this and tell it's in millimeters.
Oh, I'm glad we're doing this. I totally would have screwed that up, so this is good.
Right. Well, you can see the numbers down here,
yeah.
And so what it's telling me now is that ship today is unavailable for this product. So I'm going to get rid of this other part I tried to load where it was having server issues. But now we're in millimeters, so that was how the part was designed. So
okay.
Ship today for SLS is not available, and so that's what it's telling me here. So if I say ship in 2 days, it'll tell me, oh, okay, well, today is Thursday, right? If I place the order today, it will ship in 2 business days. So Friday's 1, Monday is 2, so that's the day it will ship. We ship everything overnight, so it'll arrive the next day. So if you place that order today for that SLS part, you can expect to get the part on Tuesday. There's also, if you want to save some money, you can look up here at the top and you can see that the ship in 2 days, this is a $94.60 part. If we wanted to save some money, about $14, ship economy takes about a week to ship, and we ship at UPS ground. So again, if we look at order today on Thursday, it will actually ship on the 4th, arrive in a couple of days. UPS ground, that's in the United States, so it ships from the United States into the United States. It would take a couple of days. So international shipments, those we may have to figure out differently. So really, that's ZoomRP is really the quickest way to get parts, and it's the easiest, least confusing. But we also have, let's see if I can.
That's pretty painless. So if there is a challenge and stuff, how do they get back in touch with you to say they need it in a different format? Do they just shoot you an email? Like if there is a challenge in the upload?
They could always shoot me an email,
Okay.
and I can help straighten it out.
Okay.
Now on our Solid Concepts website, we have online quoting here, and so again, you can sign up for free. So you need an account to sign up. Again, you log in. Typing is my least favorite thing.
Hey, is there a For the guys outside the U.S., is there an ITAR restriction on having parts printed shipped by your company? Alyssa, I'm gonna unmute you too if you got a comment.
We are an ITAR facility, um, um, and shipping parts outside of the country, if they're their own parts, is not a problem. The problem is shipping United States government parts outside of the country. So your own parts, it's not a problem at all. Of course, if you want to come visit us and you're not a U.S. national, then we may have to limit the tour and what you can see. But ITAR shouldn't affect what everybody is ordering because they're their own designs and their own parts.
Okay.
Does that make sense?
Does to me. Did let's see. Oh, from Ultimator Rio. That's fun. Are you guys from Brazil, huh? Are you guys? Did that answer the question? Just shoot me an email back. There was another question that came in while you were asking for our contact emails. So I've just sent out in the links here for the questions. There's Chuck's email and my email. So if you guys, be nice to us, but but definitely get in touch. I mean, we want to get to know you.
Right. So here's a different way to order SLS. Now on the Solid Concept site, there's a lot more options, and so it could get confusing. So if we go back and we look at the ZoomRP site, the SLS, we limited it to one material. It's a nylon 12 material, and so on the quote, oops, going the wrong direction here. But anyway, on the quote, the material, and I kind of breezed through it, was SLS white. And so that's a neat nylon 12 material. It doesn't have any fillers in it. And so, but on the rapid quotes on the Solid Concept site, you can see I've selected SLS standard. So if you look here, there's a lot of options where, I can order SLA or PolyJet Flex or PolyJet HD. Now there should be, on all of these, there's, you can get help. And so it will explain what all of those options are that we have there. So it's a quick kind of explanation. So it might help you if you have a little bit of understanding. But again, UAVs, just for the simplicity of this demonstration, I'm going to recommend that you use the SLS standard product.
Do you guys have the ability to do metal?
We do.
Yeah, there you go. The question came in.
EMLS on here? Yeah.
Yeah.
So, yeah, here's a metal part that we print. If you guys can see that.
John was thinking for frames. Like, oh, look at that. That's beautiful. Yeah.
Yeah. It
obviously that's gonna be more expensive,
probably,
but yeah.
It's quite a bit expensive.
Yeah.
So, and for frames and things like that, it all depends on what you're trying to do. A lot of our process, and in selling additive manufacturing for UAVs, is actually to replace metal parts with plastic. And so, we've been surprised as to the types of parts that you can replace with plastic. Now, of course, structural parts that are going to bear load and, things like landing gear and stuff like that, probably you don't want to do with 3D printing or additive manufacturing. But again, it all depends on, that's why last time I showed you all of the material data sheets and things that we have for all of our materials. Now, DMLS is the metals process, but again, it's not inexpensive. So if things are easy to machine, that's going to be the way that you want to manufacture metal parts, is to machine them and do something like that. But again, with additive manufacturing and 3D printing in general, its benefits are speed and design complexity, because for the most part, design complexity is free with additive manufacturing. If you get behind and you don't have time to machine something, and we can do it faster with the MLS, then yeah, that could have a benefit for you, and that's one of the primary ones of additive manufacturing. So again here, just back to rapid quotes, SLS standard, that's what we do a lot of UAV parts out of. Now you're going to see you have a lot of different materials here that you can order with SLS. That SLS white that was on ZoomRP, that's this nylon 12 PA. So we have nylon 11s, we have it colored, we have it filled with carbon fiber, we have it filled with carbon fiber and hollow glass spheres if you want to make it strong and light. We have PEEK material. PEEK is high temperature, very strong material, but also again very expensive. So normally, you're staying up in this range here of the nylon 12s. AF is aluminum filled. It looks cool. It looks like an aluminum part, but it's still nylon 12. GF is glass filled, so you get better strength and higher heat deflection. But of course, you get added weight with that. But again, it's going to be lighter than aluminum or another type of metal. So this might be a way to get strength and heat deflection and those kind of things to do frames and other parts of your UAV. So I think generally you're going to stick in this GF or PA realm of the nylon 12s when you order this stuff. So you can pick one. We also have different hand finishing and surface treatment options. So that means basically we can sand parts smooth on one side or all sides. We can apply master finishes, if you're going to paint the part. Again, I don't think these things are going to be real something that you're going to need necessarily, unless looking cool is part of the design competition, or maybe looking scary if you want to scare off the poachers. So you might want to buy finishing and painting and things like that. So, but I don't know if a paint job, with a shark or something painted on it is going to be that scary, but who knows?
There's something to be said just for weatherization purposes.
Right. So there are seal coats and things like that you may want to put on. Nylon weathers pretty well. It's pretty chemically resistant, things like that. It does yellow over time, but it's real resistant to fungal growth and all of those kind of things. We sell a lot of parts that are in manned and unmanned flying vehicles. So, but most of those, then it's a good point from one of our attendees that you probably want to put a seal coat on it just to give it that little extra protection. You can do that yourself too. Any spray paints and things like that, or even hand paints, you can put on the nylon.
Actually, we did that. My team, we I don't know if you saw our video. We did this thing where we didn't think that foam. Well, we needed an excuse not to think that foam would stand up to poacher gunfire, and so we tried it with a coating versus uncoated, and it was a lot of fun. We blasted it with a shotgun and had a great time.
Right. Parts can also be, a lot of times we'll make hollow, really thin skin kind of parts, and then people will do a composite layup over it. So it's almost like creating a mandrel, and then you strengthen it with doing composite over it. So there's all kinds of things you can do with 3D printed parts. One thing I wanted to note is if you're going to print, or if you're going to paint nylon, you want to make sure that if you've been handling that part, and we're going to handle it too, the oil from your hands and your fingers can get on the part, and that may provide a barrier for the paint to adhere. So you just want to put some gloves on and wash the parts real well with soapy water to get all of that off, and then of course make sure that the parts get dried. So you can either let that happen through ambient temperature, sitting around for 24 hours or so, or you can heat the parts up if you want in an oven or something like that. So just make sure you pay attention to the material data sheet to find out where the heat deflection temperatures are and stuff like that, so you don't melt your part. But those are some of the things that you'd want to do. So anyway, you can at this point we can add a part. So this keeps, let's pick that little part again. See if I can run into the same problem of inches versus millimeters. Oh, here we go. This says it needs review, probably because it thinks it's an inch part again. So let's try changing this.
Yeah, it's interesting. We could check on the exporting settings from Fusion.
Well, again, you can change it here in the quoting interface.
Oh, okay.
So I don't know why it would need review at this point. Now, let me try just updating something here.
How'd those guys do that I sent you yesterday?
Those guys do.
The parts I sent you yesterday, they work?
Oh yeah, I was loading them up and doing different things with them, but.
Were you able to load those in the solid concepts?
Yeah, I loaded them in both places, but what I didn't check to see is if I got a price
Ah,
here.
Okay.
So I'm not sure why it's saying it needs the expertise of a project engineer. But that's one of the benefits of going through the Solid Concepts quoting website is you get to talk to an engineer. So the engineer will email you or phone you and ask you questions. So there may have been something here that where it didn't like the finish or something that I added. I don't know how to change those on the fly. I don't normally order parts from Solid Concepts, so I'm a novice user on this.
Well, thanks for sharing, Chuck.
thanks,
So,
Chuck.
okay. Now, can I ask a question? Is there a difference in price from Solid Concepts versus the Zoom RP quote?
Yeah, yeah. Actually, Zoom RP could be a little bit lower price
Oh,
because you're not talking to a project engineer. It's all
okay.
self-service,
All
and you
right.
have limited materials and things like that. So
Mhm.
depending on the delivery option you select, it might be a little bit less expensive that way.
Okay.
Um,
Chuck, you mentioned you were going to show some stuff on like kind of basic nesting of like throwing a couple parts in a space.
oh,
Were you gonna?
sure. And
Can I actually also tell the people on that are actually on here already how and what they do once they do get their rapid quote to get their grant?
Definitely.
Could I do
sure.
that? So just from our main website. Oh, you know what? Let me go ahead and share my screen then. Can I do that real
Hmm.
quick?
Yeah, you can do it.
All
Just
right.
right click and say make yourself the presenter.
All right. There we go. Can you see my screen?
Not yet.
You can.
Not yet.
All right.
Do I need to relinquish
No,
control?
no, no. Here, I'll just do it. Here, you are now the presenter. And then hit the play button.
Okay.
There we go. See it?
Okay. So once you've got your rapid quote, just go to resources. And then from here, you would just scroll down to this, click Solid Concepts and the amount that you're requesting. Now, keep in mind, this says maximum of 1,500 is what each team can request for the grant. But if it costs more than 1,500, don't worry about it. Just go ahead and fill it out and your team information, and then you can attach your file as well, and then just submit it from here. And then once we get that and review it, what we'll end up doing is I'll work with Solid Concepts on your actual design and see if we can work that out in under the $1,500 range that we have for each team that can qualify for it. And then if it goes beyond that, I know one of the things I was working with Scott on is to just give the teams a lower cost on anything that would be in excess of the $10,000 grant. So I'll go ahead and work with them. So once you get your quote, just go ahead and send it to me. And then from there, I'll work with Solid Concepts to get you guys the parts that you need. That should be it.
Okay. Back to you, Chuck.
Okay. Let's see.
Quick time.
So what I'm
quick
doing
time check
is-
too. We're at 9:30, so I guess we'll go a couple more minutes and then we'll close it.
Right.
Okay.
What happened there? So Mike sent me 3 parts yesterday, so I just wanted to give you a quick kind of tip and technique that applies to the SLS process. SLS is actually the only 3D printing process where nesting in 3D space, and that means your parts fit in a 3D chamber because it's building in a bed of powder. So actually there are cost savings that can happen by nesting parts together as you submit them. So I kind of wanted to demonstrate that. So again, I give our machine programmers a hard time all the time because I tell them, oh, their job's really simple. You know, for most of the processes that build parts on a platform, all they're doing is arranging cookies on a cookie sheet. And for the SLS process, which is building in a bed of powder, you're packing junk in a trunk. So they love it when I tell them
I
that.
bet they sure do, man. You get a lot of friends over there.
Yeah, I do. So one of them's my daughter too. So,
uh,
but they all know I'm kidding. There's a lot more to it than that. But it gets across the idea that the SLS process, because it builds in a bed of powder, you can nest parts in 3D. So what I wanted to demonstrate is here. So I've got the 3 parts. I've loaded them. They're all SLS white. You know, they're all quantity 1. And you can see that for this ship in 2 days, it's a little over $708 to get these three particular pieces, right? But what I wanted to show you is that in let's see, in solid view, or if you know, again, if you have a way to nest parts, again, since we're packing things inside of a build chamber, we're basically what we're concerned with is how much area in that build chamber do parts take up, and that is a major contributor to the cost factors. So I wanted to demonstrate here. Here I've selected the tank part, and it is, you know, it's got a particular volume of not quite 7 cubic inches for the part itself. But what I wanted to point out was the extents volume, and what the extents volume is the X length, or the Z height and the X length and the Y direction multiplied together give you the extents volume. So if you look at this, just the tank by itself, it has an extents volume of a little over 221. So if I let's see, didn't really want to do that. If I select all of the parts together, I clear this section, and then I do a measure object for all of the parts, all of the selected, you can see that when compared to the tank by itself, the part volume went up, and I had 2 extra parts in here. So I not only had the tank, I had the cap to the tank and the motor mount in there. So the part volume went up, but the extents volume didn't. It stayed the same. So the reason why that is, and let me get rid of these measurements so we can see things. But I might leave this one because it shows the extents box there. But you can see that those 2 other parts are nested inside of the extents volume of the tank itself. So what I could do is I could combine these parts together. And I'm just going to say it's a lot of 3 UAV parts. And I'm going to combine those and then save it to the directory where I was working.
Okay, so so quick to follow along here. So we are taking 3 different parts, we're combining them into one with the point of idealizing the volume that you're using. That'll in turn use less material, and it'll be done in one run, and that will decrease the cost.
Right. So here's the proof of that. So if I add that lot of 3 parts, so again, you look at ship in 2 days, $708 for the 3 parts. If I add this part, this thing we just saved.
So it's one run.
But and normally our operators are on the lookout for this kind of thing, because in other processes other than SLS, it really doesn't make, you may not get the part you expected if you try to batch things together. For instance,
yeah, there you go. Look at that. Yeah, that's
right. So this is 5. So that's a lot different than 708.
Yep.
But but you know, so things like the cap, right? The orientation that it's built and the threads and things like that, and how it's going to mate with this part, it's real forgiving in the SLS process because we're building in nylon Actually, the resolution in Z is better than the resolution in X and Y. And so part orientation doesn't have as dramatic effect on the part quality. Um, in other processes, all the other processes, part orientation does have a dramatic effect on part quality. And so if you were to submit this lot of 3 UAV parts as for stereo, for SLA or for PolyJet or FDM, um, our operator, we may come back and say, hey, you really can't batch these together because we need the freedom to treat each of these files separately and how we orient them to build them so that you're going to be happy with the quality of part that you get back. So, but anyway, I just wanted to demonstrate that. Another thing that is important to note is that when you're, again, for the SLS process, and that's where we build most of the UAV parts that we build, but let's say that you're designing in your 3D space and, depending on the particular design, let's say that that a part, for some reason in your design world, it comes out of the CAD system and it's got an angle on it. So I don't know if you remembered that that extents volume we had before. It was a little over 221 cubic inches. But if we go back and you can see I've angled this now in relationship to the CAD space, and that might be how you're designing it. So if you look at the top, actually, if you look at the left, you can see that angle as in relationship to to your CAD world here, or your origin. So what that does is it will drive up the extents volumes. So you can see that the extents volume went from 221 to 309. The material calculation, because what it's figuring here is that, this part's going to take up more space in the build, so it's going to use more material, and so it's going to increase the price. So when you submit parts, you want to make sure that they're squared up to the origin space, to have as small of an extents volume as possible. And again, that will help with all of the processes, but especially for SLS. That's how you're going to get a correct price for those parts. So that's about all I've got.
That's good. That's a good tip, man. I've totally made that mistake. As a matter of fact, I have videos posted on lines where I make that mistake. So I need to go.
Well, and
Yeah.
when we build it, we normally square it up, right?
Yeah.
Because so you just end up spending more money and you get actually a better part because we square it up and build it that way. But
that's very cool. I'm looking forward to taking advantage of that. Okay, so I guess maybe we'll bring this guy to a close, huh? I guess we didn't quite get to finish your motor mount, but so call to action from this, guys. There's a couple of things. I mean, we want you to be successful in modeling. So if you guys want to reach out to me and Chuck, I mean, we can. Well, I will help you model. Chuck will help you get stuff, get you in touch with the right people to get it printed. So definitely reach out to us directly as you see stuff. And then open invitation, actually, Princess Aliyah, if you want me, and actually, of course, Chuck too,
Yeah.
if you want me to do another one of these sessions where we do stuff more in depth or maybe model some more
I
specific
think
things.
I think that would be great. I think we could definitely schedule something the teams would really benefit from it. And if there's something that one of the teams wants us to design, I mean, I think that would be a great way of being interactive, and perhaps we can have the person from that team come on and actually design it
Yeah,
as we're showing them how to do that. So that could be pretty interactive as well.
I like that idea. Yeah.
this webinar was a winner for me because now I've got
Dude,
360
Chuck,
on
I
my
had so much fun, man. We're gonna do some more modeling together. That was a blast.
Is he Chuck Super
Super
Chuck for
Chuck.
his
Yeah, we
login
got to
now?
change your name, man. You're gonna have to get a different account. You got to be Super Chuck.
Yeah. Well,
Do we have any questions from the teams or suggestions on the webinars? If there's anything else they want to see from us as well,
Let's see what
can we
comes
open it
in.
up for questions?
I've been doing a pretty good job
Yeah, you have.
of keeping on top of the questions. There's a lot of compliments here. I'm hearing good stuff like John Bennett saying, "Yeah, the more the better." Um, and then John wishes he had that Chuck. And let's see here. Yeah, I don't think we've. I think I got the bulk of the questions
You've
here.
covered, yeah, I think you've covered the questions along the way. So if there aren't any other questions, go ahead and actually shoot me an email on suggestions for other webinars that you guys would like to see. And then possibly for our webinar with Mike, designing a motor mount, or if there's a suggestion from the team that they want us to design something that they've thought of, we'd be happy to work with them on a webinar geared towards that in particular.
Okay, so good stuff coming. So a couple questions coming. Thanks for the compliments, guys. I mean, that's awesome that you guys are. I got people downloading it, people saying this is useful. That's good feedback for us. Thanks. Quick question from Michael asking, how many people are here today? At our peak, we had, I think it was like 22 or so. I mean, obviously we've been going a little long here, so people have been dropping off. Right now there are 17 of you, and there are 4 of us on the panel. So yeah, we have a good turnout here today. I mean, this is kind of that
Yeah.
sweet spot of where we can, there's enough people around to ask questions and get into depth, but then also we're able to pay attention on an individual basis. So this was perfect. Um, Hey, Chuck, if they have some stuff modeled in SolidWorks, you guys are good to take SolidWorks format, or do they need to give you like a step or like a
Absolutely. Yeah, absolutely. I mean, we
yeah?
can SolidWorks Pro Engineer. We have SolidView actually has a lot of translators in it, and then we have other translators from native CAD. So, um, but when in doubt, IGES and STEP, and then we're in control of the resolution of the STL file, or just send an STL file if it's not if it's too coarse in its resolution. If it's not finely enough resolved, we'll just give you a call or an email and let you know that, hey, you know, um, either give us a better STL file or a more finely resolved STL file, or send us the native or IGES or STEP files.
Um,
But we have
so just a quick
lot of them.
to quick add to that, actually, with SolidWorks, we actually see Fusion as being a complementary tool to SolidWorks as well. For those of you guys who have used SolidWorks, it's a really good parametric modeler that you can establish a bunch of relationships between different parts. Fusion's actually very flexible. If you get to a point where maybe if you've built out your whole model in SolidWorks, but you want to make a change that isn't conducive to the way you modeled it, your faster method might be, rather than trying to rebuild in SolidWorks, if you want to take your SolidWorks file, pull it into Fusion, there's actually ways to just directly edit it in Fusion, and you might be able to save
Oh,
yourself some time there. So I've done that with success with SolidWorks parts, and I've done it with Pro E as well. So actually, if you get yourself into a corner there, Joshua, I mean, I use SolidWorks in college. And actually professionally, I worked in actually a simulation environment where I did a lot of stuff in SolidWorks too. So actually, I am a SolidWorks user too, in addition for working for I guess the competitor. But but it's a great tool. So I mean, let's see where what you need to model, and then kind of make sure you have the right tool to get it done. See your printing lab question, John. You got to ask a question, man. Printing lab, that means nothing. What do you got? You just wrote John, printing lab. Uh, oh yeah, Chuck. Where is your lab? Where are you based? That's the question.
Well, actually, we have 7 different manufacturing plants in North America. So from a worldwide standpoint, where all the 3D printing is in North America right now, we're getting ready to open a facility in Sao Paulo.
Nice.
So if you want to get more specific in North America, I can. I mean, where my office is in Valencia, California, that's where we have the most 3D printing equipment. But certain things like DMLS, that's in our Austin facility, and we coordinate and we try to load balance between all of our facilities and where the machines are, because our core competency really here at Solid Concepts is rapid delivery. And so we're looking for the fastest way to get you the parts. So like Zoom RP, you notice that little timer on there. To get an order shipped today, you could place an order by 4 p.m. Eastern Standard Time, and we take advantage of that 3-hour time difference here on the West Coast, and that's where we're doing our manufacturing for the bulk of the Zoom, and so we can get that shipped out because we're 3 hours behind you, so we can get it shipped out. So we get an extra 3 hours in order to build and ship parts. So we're trying to turn this more and more global, and again, focusing on getting things out very quickly.
So John is a neighbor of yours, which is awesome. So yeah, he's down in California, uh, so Los Angeles area. I'm not seeing any new questions coming in.
All right.
Okay, I guess so with that, I will be posting this online probably in the next couple of days. It takes some time to render, so it won't be, it takes a little bit of time. So that'll be coming up, and then yeah, and Princess Aliyah will be getting you guys and get in touch with you guys about future engagements and future webinars. And then feel free to
Yeah.
reach out to any of us if you guys have questions. So
Now, I would like to know, does this time work for most of you? I guess most of you that are online, it probably is a good time. Or could we go a little bit later? Because I know Mike and Chuck had to start early. 8
8 a.m. is not,
a.m. is
it's not
early.
that bad. It's okay.
But
Yeah.
I mean, I wanted to know if the people on the other side of the world also find it to be something that would be helpful for them if we pushed it an hour later. So that would be nice to get some feedback on timing for the webinars. If you think, there's certain days that you guys would like to see these happen, as well as timing wise, we can try to work those in to the next seminars or the webinars that we would be hosting.
Guess we could. Joshua wrote back and said from South Africa that 2 hours later would be okay for him.
Okay.
Uh, we could just try one at maybe a later time or something. We
Yeah.
could always stagger it. I know that I mean, with my team because the 8 a.m. is when they're trying to get to work. I mean, so it's like if we had,
Yeah.
we could try something, maybe in the later afternoon, West Coast time. That
Right.
would, I mean, that'd kill us for the guys in Africa, but that might be a little more conducive to the people in
Yeah,
the
because I
Americas.
think 11, yeah, 11, I think this was a 6 p.m. South African
Yeah.
time. So if we push to maybe like 8 p.m. South African time, that still kind of gets a lot of people around the world a bit covered, especially if they're getting off work on that side. So perhaps next one we can look at 2 hours later than the one we started here.
Okay, so John says that he works nights, so actually that's not so awesome for him. Um,
So,
well, let's.
well,
I'm
Yep.
if
Just
we're just doing kind of one-on-one stuff, if it's kind of more modeling and stuff, I'm totally willing to do kind of split sessions. I mean, if we have a group of people that want to do it one time or another, I mean, it's it's best if we can merge them, we do, but it's not the end of the world if we do 2 sessions.
all
right.
right, sounds good.
And yeah, I'm fine early too. So I grew up on a ranch, so getting up before the sun was required.
Okay, all right. Well, a good thing I'm on the East Coast, so that gives me an extra 3 hours.
Yeah, yeah, it sure does. Yeah, you guys always remind us of that.
Yep.
That's right. So, thanks for doing the webinar. I think you guys are a fantastic team. This
Oh,
was
thanks.
very, very helpful. And I know I'm going to be doing some private lessons on learning
Yeah.
Fusion 360
Yes.
and starting to design my own stuff, maybe even some artwork or something, and have it 3D printed.
Absolutely.
Because I know that's another area that 3D printing is getting into as well. So,
Awesome.
That's awesome.
Yeah,
All right, friends.
I thoroughly enjoyed myself. So thank you
Yeah,
for including
this is
me.
this was this was a lot of fun, guys. Yeah, thanks for joining
Thanks.
us,
all right.
and we'll see you next time.
All
Yep.
right. Have a good one,
Bye, guys.
guys. Take
Bye.
care. Bye.